Vector in physics is a quantity that has both magnitude and direction. It is typically represented by an arrow.
When you break a vector into parts, those parts are called components.
Hi, vectors are broken down into components. Now let's take a look. Say you went 1 unit east and then another unit east. How far did you go? So you do 1 plus 1 equals 2 units.
Oh, didn't see you there.
Welcome back. Let's try some more. Pay attention, it gets harder. For example, if a ball is rolling north 5 centimeters, then rolls east 3 centimeters, you need to find its total distance, which is the hypotenuse of the triangle created by the two components.
Trigonometry is needed to solve this. First using the Pythagorean theorem, then using sine, cosine, and tangent, also known as SOHCAHTOA.
So is the opposite side over the hypotenuse. Ca is the adjacent side over the hypotenuse, and toa is the opposite side over the adjacent side.
The Pythagorean theorem is a squared plus b squared equals c squared.
Now let's try some problems.
Problem number 1. A 4.73 meter ladder leans against a wall at an angle of 30.6 degrees to the wall. What distance from the wall is the base of the ladder?
Okay, so first you draw the problem. So we're going to draw the wall first, and then the ladder, and this is the base. Then you want to draw the angle in, and that's 30.6 degrees, and the length of the ladder, which is 4.73 meters. For this problem, and this is what you want to find, for this problem, we're going to use sine. So the equation for sine is sine theta equals opposite over hypotenuse. Next, you plug the numbers that you know in. So we're going to do sine of 30.6 degrees equals the opposite, which we don't know, so we're going to put an x, over 4.73 meters. Now you multiply 4.73 times sine of 30.6 degrees. And that equals x. Then you plug it into your calculator. So you do 4.73 sine 30.6. And the answer we get is 2.407, which is rounded to 2.41 meters.
Problem number 2. A hiker walked 4 kilometers east and 6.87 kilometers north. What distance did the hiker walk? And what is the magnitude of the hiker's displacement?
Okay, so first draw the problem. So he walked 4 kilometers east and then 6.87 kilometers north. To find the distance, you add everywhere that he's walked. So you do 4 kilometers plus 6.87 kilometers equals 10.87 kilometers. To find his displacement, we use the Pythagorean theorem, which is a squared plus b squared equals c squared. So you plug it in, and it's 4 kilometers squared plus 6.87 kilometers squared equals c squared. And you do it on your calculator. So it's 4 squared plus 6.87 squared equals 63.1969. Then you have to find the square root of that. And that equals 7.95 kilometers.
Problem number 3. A horse rider rode her horse for a distance of 48.7 meters east, 67.7 degrees north. What is the northward component of the rider's displacement? What is the rider's eastward displacement?
First, draw your compass. So this is north and this is east, and this way is east of north. Then you draw in your triangle, and this is the way the rider rode her horse, and she rode it for a distance of 48.7 meters, and she's at an angle of 67.7 degrees. And we want to find the northward component first, which is here. So for this problem, use sine. An equation is sine of theta equals opposite over hypotenuse. Now plug everything in. So sine of 67.7 degrees equals x over 48.7 meters. Now you do 48.7 meters times sine. So you do 48.7 meters times sine of 67.7 equals x. Now you plug it in. 48.7 times sine of 67.7 equals 45.06 meters. For the second part of the problem, you use cosine because you want to find this. So cosine of theta equals adjacent over hypotenuse, and plug it in. The equation we're going to use is cosine theta equals adjacent over hypotenuse. So then you plug it in. Cosine of 67.7 degrees equals x over 48.7 meters. Then you want to multiply 48.7 times the cosine of 67.7 degrees. Then plug it in your calculator. 48.7 times the cosine of 67.7. That equals 18.48 meters.
Oh, where'd you come from again?
Thanks for watching. I hope you learned something.
Thank you. Goodbye.